It just makes me sad. Every day I leave this class, my day's ruined.
I apologize, your day is ruined. But hey, it can only get better after this class.
No, it's just never gonna recover. That's where my first hour. I love.
Well, you know what? How about this? Screw all of you. I'm sorry that you might think that. So here we go. So basically, we are going to be simplifying, multiplying, dividing rational expressions. So here's what happens. In order to do this, when you start these things out, you always have to factor. So anytime there's a problem that you're going to write down, what I want you to do is factor it as you're writing it down. So what times what's negative 12? You add together to get negative 4. And isn't the denominator a difference of squares? So when you do these things, the main rule is that you cannot simplify anything over addition. It is illegal to cross off x squareds in the fours and all that. You cannot do that over addition or subtraction. The only time you can simplify stuff out is when you have things written out as terms or multiplication. Okay. So in this case here, what is the same term in both the top and the bottom? So this is where it becomes rather cathartic. And you're left with x minus 2 x minus 6 over x minus 2. You basically simplified out a pair of 1. It's simplifying a fraction that has variables in it. It's all this is, guys. Really all it is.
You just factor it out and then you can cross off whatever.
Yep, and that's what it is, because what's x plus 2 divided by x plus 2? 1. That's how that works. Okay? So you're looking for pairs of 1s to take out. Yes, sir? You're done. There's nothing else you can do. There's no solving here. You cannot simplify this any further. You are done because you have the subtraction pieces there. The only other thing I can ask you right now is what can't x be?
0. 6 and
2. It can't be 2. If it's 6, what's 6 minus 6? What's 6 minus 2? What's 0 divided by 4? 0. But can I divide by 0? No. So 2 would be my excluded value. Okay. That's where this comes into play. All right. Same idea. Even if it gets to larger stuff when you multiply. When you start thinking about multiplying fractions, when you multiply fractions, you multiply straight across. So don't write this down as you're looking at it. Factor it as you go. When you're looking at that first the top left, 4x minus 4x squared, what do they have in common? 4x. So you write it down as you're factoring it. 4x, you're left with 1 minus x in the denominator. What times what's negative 3? You add together to get 2. 3 and 1. Okay? Just keep going piece by piece. And then you get to have some fun.
Well, it doesn't matter on what side.
Nope. Yep. So when you're left here, now you have 1 minus x, x minus 2, and x minus 1. Brandon, what do you got?
Will it usually work out well enough that you can cross off a lot?
It depends. It just depends. Okay. Some of them are simplifiable, some of them aren't. Okay.
So it's not me.
X, 1 minus x, it's just x minus 1 times negative 1.
And I was just getting
So
to
it's
that.
like reduced to x minus 2 over negative 1. So
Correct.
negative x minus 2.
Yep. Ben? That's what he was just getting at. Exactly. I was waiting to get to that spot here. What happens now is, a couple of you guys have noticed, see how you have a 1 minus x, and then the denominator you have an x minus 1? They're very close to one another. The idea is, if you take this 1 minus x, and I'll just do this off to the side here. If I take out a negative 1, you get negative 1 plus x, which is x minus 1, correct? And that's one of the little tricks that you will see. Whether it's like an x minus 2, I don't know, 2 minus x, that little change of sign trick shows up. So if you see something like that, try it. See if you can take out a negative 1. And just like you guys were saying, this becomes negative 1, x minus 1, and then x minus 2 over the x minus 1. And I would just go ahead and go, my final answer would have just been negative 1, and then x minus 2. You don't have to multiply it out. If you put it over negative 1, that would have been fine also. There's no reason to. It's just an extra step that you could screw up. Because what happens in the graph of that one, you get holes. And that's something, we'll get to those later. Right. Just off of this first piece here. Yeah, think of it as a GCF.
What's that one inch have to take out?
Oh. Where are we at? Back to negative 1?
Yeah.
Well, can I take a 1 on anything? Remember, if I have, and I want to take a negative 1 out of it, if I take negative 1 out of this, I get negative x plus 3. Because if I distribute in, I get x minus 3. That's all I'm doing. And then you just flip the order. Okay. What happens if you have what are called monomials? Don't hate those.
We still hate those.
When I have monomials, guys, what I want to do is I always write my numbers down first, then I put my variables next to each other that are the same, and I just put them all in order. Okay? So in this example, what I would do first is I'm writing it down. I'd write big fraction bar, 5 times 6, x squared, x cubed, y squared. All I'm doing is just rewriting the numerator. Do the same thing with the denominator. 2 times 10, x, y cubed, y. And then I go piece by piece. What's 5 times 6? What's 30 divided by 10? 3. So my numbers become 3 halves. I can simplify my numbers there. Or, if you remembered how to simplify fractions with numbers, 2 goes into 6 3 times, 5 goes into 10 twice. 3 halves. Same thing. Okay. How many x's do you have in the numerator? Got what?
5.
Good. Remember, when you have the same base, this means x squared means x times x. This means x times x times x.
Yeah.
Did I say 3 times? Yes. So now there's 5 of them, which means it's now x to the 5th, y to the 3rd. Down here is just an x, and y to the 4th. We haven't done this part yet, though. But, yes, sir.
Why can't you just take, since you have 3 y's on the top and 3 y's on the bottom, can you just take
I'm getting to that. Okay, I'm getting to that. And you could have done that right there as well. I usually like to put it all together first, because now, you guys ever play the game War with cards?
Yes.
The premise of that is high card wins, right? Okay, so treat the variables the same way. So you have an x in the numerator, x in the denominator. What is the exponent of the variable in the denominator of x? 1. What's bigger, 5 or 1? 5. So what's 5 minus 1? 4. Okay. So your numerator becomes 3x to the 4th. Because remember, that's just 5 x's, and there's 1 x in the bottom, so one pair comes out. Over 2y, very good. Yep, and it becomes over 2y because in this case, the 4 wins. So that means it stays in the denominator. Okay, and that's how it would work. Really fast.
Is that the last? Is there another spot?
Nope. Okay, sorry. Yes, but I always play war because it's easier. It means the same thing.
No, I mean, is there another spot?
What do you mean, like another problem off of this? No, let's just simplify it. Alright, let's just simplify it. Multiply, simplify, kind of same thing.
Yeah, that's what I meant. Whatever.
Multiply, simplify, it's kind of the same thing here. Uh-oh. You're right, put it over 1, good. So if I put this over 1, that doesn't change anything, but how do you factor 8x cubed minus 1? Yes, sir. Maybe 2x minus 1, good. All right, so numerator doesn't change, x plus 3. I get 2x minus 1. All right, finish it out. What's the last bit?
Why?
4x squared plus 2x, then what? It's factoring in trinomial, guys. You did that yesterday, you did that last week. It doesn't go away. Okay?
And then we can take out the 1 from
The what? What's the same?
Just cross out the way.
The trinomial's the same, isn't it? It is, isn't it? And you're left with x plus 3 over 2x minus 1. There's a 1 there, yeah, there is. You're right. Can I do anything with that, though?
No.
Nope. Notice, I have not once tried to cross off an x over addition, have I? No, because it's unmappable. Can't do that. Can't simplify over addition. Okay? You only simplify when it's multiplying. Oh, speaking of multiplying, what's dividing?
The opposite.
What do you do if you have a fraction with dividing? Yep. All right. So when you see the division ones like this, same rules apply. You write things down, but as you're writing it down, you factor it as you're going. So 5x, can you factor anything with 5x? Three x minus 12, what do you get?
3 times x minus 4.
Yep, 3 times the quantity, x minus 4. Now I'm going to multiply, which means I have to flip my second one. So my new numerator will be what times what's 8, you add together, you get negative 6. And what's the GCF of x squared minus 2x? Well, this might be satisfying. Ready? When you divide by 2, it's the same thing as multiplying by 1/2. Just flip the fraction. Multiply by the reciprocal. What's 4 divided by 2? It's 2, right? Isn't that the same thing as 4 times 1/2? It's the same thing. So here, satisfying now. Yeah, it's multiplying. Go straight across.
Wait, then why didn't you do that?
Because there's an addition symbol. Cannot break things apart with addition or subtraction. Can only take out pairs that are multiplied.
Oh, I see. Because there's no
What fun would that be?
You don't like doing math?
It's better than doing math. Well, I wouldn't go, maybe, I don't know. Oh, it reminds me, I gotta show you guys a clip one of these days. Yeah. Oh. I'll show you guys after this one. I'll show you what I'm talking about.
Meth? Did you say meth?
Yeah. Anyway, guys, last one. Does it change if you have leading term coefficient that's not equal to 1? No, you still got to factor it. So what times what? What times what is negative 18? You add together to get positive 7. 9 and negative 2. So you have to factor that one via grouping. So you have 6x squared minus 2x plus 9x minus 3, which will give you 2x, 3x minus 1. So your numerator will become 2x plus 3, 3x minus 1, 6x squared. And what's the GCF of the other one? x. But now it's divided by 2x squared plus 3, so that means it's going to be 1 over that. This one's not as satisfying, unfortunately. So your numerator becomes 3x minus 1. What's your denominator become? 6x cubed. Because you have x squared and an x. Oh, I thought you said squared. I'm sorry. My bad. I thought you said cubed. Never mind. No. There's a subtraction symbol which makes you no. You cannot do that. What times what is negative 18 to get to 7, negative 2 and 9. Factor via grouping. There's my terms.
Okay, so that's, oh.
You have to do a bunch of this. Yep.
Okay.
Yep. Don, what do you got, sir?
Well, I was just going to add something on.
Oh, good job.
So when can I simplify the,
Can't. Only when it's multiplying. Only when it's multiplying.
so it's what?
If-
3x times?
If it was, then you could take out an x. Okay, but you can't do that. If it was just 3x, then you could. All right. Do those. And I'll show you the video I was talking about, because it's very funny. On the count.